Titigu. Any Titigu now? Hello? Hello?
Hello, Professor. This is Mary.
Mary, okay, Mary, yeah. I was wondering if it's Titigu. Mary. How are you today, Mary?
I'm good, sir.
Pray now. Miss Owotutu, how are you? Hello, Miss Owotutu, how are you?
I'm fine. How are you?
Good.
Professor.
Yes, ma'am.
I have a couple of questions.
Go ahead.
The project, I saw the data, but I didn't see any question. What is this all about?
Questions are there, really, actually.
Huh?
Yeah, when did you check it last?
I check it. I think I can check it now. So
Yeah, go ahead. The questions are there.
The questions are there now.
Yeah, both of them are there.
Professor.
There are two links. One is for the data set, one is for the question.
Okay, let me quickly check so that I'll maybe it's asking question. Let me check them.
Yes, Mary, are you asking a question?
Yes. So one is the project, right? The population mean you get to us for the class limit. Do you want us to use the same thing for the hypothesis and the null and alternative and all that? Because you were like, we should find the mean population and
Can you ask it again?
Okay, so this is it. The project, right?
Yes.
So we have hold on a second because I want to go through it now. So I could okay, so this is it. So you ask us to get the alternative hypothesis, the null hypothesis, the critical value, the test statistics and all that. With what what's the value and everything, because I don't understand. Are we still using the same
yeah, data sets. You have data sets. If you find the
so can you just, because it is kind of challenging. I just, it is quite challenging.
Oh, okay. So I can see the instruction on the number 2. Okay.
And then doing the histogram and all the diagrams and all that, that is just.
Yeah, those diagrams you can do them in Excel.
I know, but it's just time taking because I'm using MacBook, so there are some things I can do on computer and on this one, so everything is just kind of different.
See, if you're using MacBook, check our YouTube on how to do some of those things.
Yeah, I watched different YouTube videos yesterday.
Daniel,
it's just one of those things. Remember his college.
But Professor, can you just like, even if it's not the same question but something different, can you just like briefly go through it, because I just don't understand.
I'm opening it now. I'll open it now so I can.
Okay.
Professor, but I mean, to the end of the semester, those assignments are just too much. We are taking other classes.
No, those assignments have been there for a long time.
No, like you said, they are due like. But the discussion and all that, I thought we were done with discussion. Then you brought another 2.
When is everything due anyway? I put everything due when again?
Most of it are due to tomorrow. And
I can move the due date to next weekend. If that's
okay, that will be fine. So that maybe by that time we will have been finished with the other classes. Then we can.
I can move the due date for the assignment to next week.
Yeah, because they're just too much because we have other classes,
And there are only few of them anyway. The only few assignments, I think.
No, the assignment that I do this weekend is about like the discussion is 2, the homework is 3.
Yeah. Miss Owotutu, right? Owotutu, right?
Yes, sir.
Yeah. those assignments that are due this weekend, I can move them all. Those that are due to next Saturday.
What about the quiz? The quiz 4 is due this weekend too.
Yeah, those assignments that are due this weekend, I can move them to the due date to next week. No problem. I can do that. So
even if you don't mind, you can move the statistics project too, because that one is.
No, the statistic is not due today. It's not due this weekend. He said it's the end of the semester, like the last day.
If I wrote that it's due this weekend, that means I will change it to next weekend, so that you have more time. There's no problem. I have no problem with that.
Thank you.
But they have to be completed.
Yeah, it is due. It is due tomorrow on the 13th.
So I'll move it to next weekend then.
Okay, sir.
If I don't do it today, then I'll do it tomorrow. Make sure I move it to next weekend so that we'll have more time.
Did you just wake up?
Huh?
Did you just wake up?
Why are you asking?
Because your eyes were swelling.
I went to sleep late last night. I was working. I worked late. Yeah, that's why.
But so one more thing, can you please, even if it's not the same data set and all that, but can you just go through it with us, because
I'm about to open it now.
Thank you.
The thing that you guys were asking me so many questions at the same time, so that's why I'm slow a little bit. So I'll open it now. Highlight this is statistics pro. Now let me share the screen with you. Now this is the.
Do you give extra credits, Professor?
Sorry, I don't give extra credit. That's why I'm flexible with.
Even if it's just for attendance, you can just give extra credit, like 2 points or two marks.
Well, see, what I give second chances. That's why I don't use extra credit. Yeah, I'm flexible with due date.
Yeah, we know, but then you can just just dash us some 2 marks.
You know how many questions you asked me this morning? I was counting. It's almost.
You know what?
It's almost 10 questions you asked me already.
The grades are not smiling, so you can
then Miss So, what you have asked me like 7.
I'm telling you.
No, that's
I'm telling you, we've been harassed with this classes.
Professor, if God should put it in your mind, you can be gracious unto us and give extra credit, sir.
Well, what I might do is after doing all the grade, before I submit the final grade, I might give extra 10 points.
Oh, thank you.
5 or 10 points,
Thank you, Professor.
You're welcome. So now look at this. Look at this. This is the project right here. You can see it, right?
Yes.
Okay, I click on it. Then see the data set. Okay, you know that one already. So now this is the project itself. The instructions here. Okay, good. Make sure you can see it. Okay. All right. See the directions here. So now the data you use that data set to do this work here. Get the boundary, and then class boundaries. You get it in Excel. Then you can type them in here, or even you can even write them in. Okay. Now you can even create your own table or your own what is called Word document, and just create this table. Type your own, because I like them typed. So now you to have a cover page. Then you create this table, get your frequency distribution. See here, let me show you something here. Let me show you something in Excel real quick for the project. Hello. Yeah. So this is the what is it again? Suppose I have this. Suppose I have these numbers. Okay. You can see the screen, right?
Yes, Professor.
We have F. I'm trying to create a data set. Okay. Then, okay, so 1. Then I have this And I have okay. Then what else do I need to have? Okay, now so let's say I have the data set, and then I have long data set like this. And I want to create a table fast. It doesn't have to be exactly with what I have here. You know, you can make it. You know, it can be. You can use a different. So I use different class width. So now, and you're using Excel. Where is my Excel? Should be here. Okay, now this is the Excel. Now use what you call bin. Bin is the interval. Okay, bin is the interval. Call it bin. You can type bin here if you like. Excel call it bin, the interval. So you can say, okay, bin start from 0. You can decide to use class width of 5. If you want, you can use 3. Anything, but I use 5. 5 is more common. 5, 10, 15, 20, 25, 30, 35. Hold on, let me check this attendance. Take it down. No, 40, 45, 50. Now, if you're using a 6, class width of 6, you can use 6, 0, 6, 12, 18, you know, like that. Now, to make a what do you call it? Frequency distribution, the class width is very, very fast. All you have to do, I've already explained to you how you get your data. Click on data analysis here. Mine is a little bit slow. Okay. We have the table is not here. Okay, this is for histogram. This is for histogram. But the histogram, it will create the table anyway. So let's use it. Histogram. And then the input. Click on the input, which is your data set. Okay. Now, why do I stop at 50? Because the biggest number here is 50. Okay. Then bin is your class width. So you click on see the bin range. You click on bin range. Yeah. Give me 1 minute. I want to change something. I want to change something. Give me 1 minute. Let me add. Doesn't matter really. Doesn't matter. So let's say data analytics, histogram. Even though it's histogram, it will also create the frequency distribution table. I mean the class width, and you know. And this is the bin. From here, get the bin. Then no label, so because we didn't include the titles, but only you can include labels if you want. Then output range. Output is where you want to put it. I can put it here. Okay. Then chart output. It didn't show me other this thing, so I can put the okay, maybe say chart output. Okay, let's see what it gives us. See, it gave us the bin and frequency. You can see the table here. Now you can use this, but this might, if you use this, it might affect your calculation. So now you know that from 0 to 5 is 6. See, then from 6 to 10 is 0. Then from 11 to 15 is 6. Yeah, that's when you'll be writing it in your chart. here. 0 is right. 0 to 5. We give you see 0 to 5. See 0 to 5, and in the Excel, that gives you 0 to 5, give you 6. See, so you write a frequency at 6. Then 6 to 10 is 0. Then 11 to 15, 6. And so this make it faster for you instead of trying to calculate it and find the class weight and So that's what I wanted to show you. And it automatically draw the graph histogram for you, which you can change. You can come here and change it, change the titles. You can change the title here. So it gives you the table and the frequency. You change the title here, to let's say age, frequency, and so on and so forth. So that's what I wanted to show you. Now we can go back to the project. I'll move this. Now we have all these are very histogram. You can copy it. See what we just drew. Remember, you might be doing this here, even though this is the questions. You might type here, open a new Word document. Then you follow the directions here to answer the question in the document. So if this is a Word document, for example, I can easily copy this that we just drew. The see, this is the histogram it gave us. After formatting it, I can go here, click here, then copy it, and go to any Word document that you are using for your project, and then paste it there. See, it's there. So after doing all the work you want to do on it, yeah, in Excel, changing the title and everything, you can just copy it and then paste it there. Okay. So this is Excel. Yeah. Now, one more thing I want to explain is this about the project is it's right here. What Ms. Mary was asking me. Of course, the median and mode, you're gonna use Excel to calculate them. Like in my own here, if you still remember, I'm gonna move this. The median, or let's say average, just use the formulas that Stefan said. Let's say the mean equals average. Then you highlight all of them, all the way to the last example.
Professor, so you want us to put all the answer inside the Word document that we got from you?
Yeah. What you have here.
And type it after getting it from there, or we have to upload it from there?
What you have here is not a Word document. It's a it's a Word document. Yeah, it's a Word document.
So okay. I'm saying, can we type the answer into that, what you gave us?
Yes.
If you have to create another one.
Yes, you can. If you can't type it in, then create another one for yourself. I'm just follow the instruction here. You make sure you put the cover page, your name, and and project. And that is if you can't type it here, but I'm sure you can type it in here. I want everything to be typed. So now, so you can see that the average, which is the mean, is easy to calculate in Excel. See, just type in the right formula, say average, then highlight all of them, and then press Enter key. Another one is this, the median. If you want to get the median, type the median. Okay, you do equal. Make sure before you type the formula, you put an equal sign first, then type median. Once it shows up, double click on it. Then highlight everything from here all the way to the last data set. Okay, close the parenthesis, and press Enter key. See, it gives you the result. So you make the whole thing easy. And don't forget, we have a tutor too that can also you do next week. Can also, I posted an announcement about him. You can look at his schedule, and then see what he can help you with. Then Mary, let me look at answer your question. You say that Mary, you're still there, right?
Yes, Professor, I'm here.
Good. We have the mean, mid, range, and standard deviation. Okay, this is for 5-number summary. Yeah, 5-number summary. Q1 is the same thing. Let's say that you have my number, for example. I have these numbers. I want to find Q1, right? So let's say I want to find Q1. Q1 is the first quartile. So type equal quartile. Once you type Q, you see this shows up. Quartile, use this one, quartile.exe. See? Then highlight everything from here all the way to the last one. Then close the parenthesis. Press the Enter key. It will give you the okay, I think I missed something. Because it is first quartile. Put comma. Oh, let me redo it. Okay. Let me redo it. Then I highlight everything from here. Okay, comma. Now, see, once you put the comma, see the first quartile is 1 is for first quartile, 2 is for second quartile, which they call median, 3, 4 is for the third quartile. So if I put 3 now, it will give me the third quartile. But we're looking for first quartile, so I'm going to put 1, close the parenthesis, then press the Enter key. It gives me 5. That's the first quartile right there. You see? And so on and so forth. And if you want to find the largest, you can sort it out from here, see which one number is largest, and then do the difference. Now, back to the project again. Then. Now let's see. Yeah. Okay. So now I say test statistic. So Mary, what was your question again?
How do we get all this? Because I don't know what numbers to use and all that. Is it the same data set you gave to us? Or?
Yes. Now, Excel, make it just when you come to this point, mention that after the null hypothesis, I can't tell you null hypothesis because you have to study by yourself. Remember, we did that last week.
Mm-hmm.
Now, from after the
question exactly is how do we get the median? The mean.
I will show you in a minute because if you want to use it manually, get it manually like we did last week. Use the mean. You can make your own assumption. See, you can make because this didn't give you the population mean, right?
Mm-hmm.
So you get your sample mean, then make any assumption.
Yeah. Professor, sorry, let me quickly ask you before you leave. That population mean, the table doesn't give us. The homework that I did, I got all the population wrong because once it's sample mean is so very
sample mean is what you will get from that data set.
Yeah.
It didn't give you the population mean.
No, so, and the homework is saying use the table.
But where did it say use the table?
In the homework, like we say use the table, use the P whatever table.
Oh, in homework 17.
But that's online, right? That one is different. We did that one last week. Use the table. I did examples how to get the P value.
Yeah, but once I use the table is population, but it saying use the table. Once I use the table, I got it wrong. That's what I'm saying.
I don't know exactly how you did it, but if you follow the step with last week.
This time I just want to get.
Now for the project though, get a sample mean. I just showed you how to get the mean. Now there are 2 ways. If you're doing it manually, what you can do is you get the population sample mean, then you can make an assumed mean. Let's say if your sample mean is, let's say it's 400, you can just make an assumption that the population mean is, because this project is a department project. I didn't create it. So I don't know why they didn't put the population.
So sorry to disturb. What I actually did was I used the same mean I got from the, from the previous one, the same data set, and I used the number of the data set, the total number of the data set as like 30 for the sample mean.
Let's say I didn't get what you said, Miss Mary, but what I'm trying to say is that suppose that your sample mean is 400 or 30, whatever it is, because you are not giving the population mean. You can make an assumption population mean is 35, or just to be able to do it manually. But if you're doing it with Excel, you don't have to go through all that. You see what I mean? So I'm going to show you what to do. Excel will give you all these results in one. You know why you go to a store, and you go to a store and you got everything at once in one store. That's what Excel does. So now for this, we have. I will show you in a minute. Now, let me remove this. Okay, let me share this first of all. See if this shows. Can you see this? Hello?
Yes.
Okay, can see. Okay, good. Now, let me remove this graph so we can have enough room. Okay, now, so I'm going to remove this one too. So this is my data set. I want to find answer all these questions here. The hypothesis test, this H1, I leave that for you. Even the person who put this together, HO should come first. But like I say, this is departmental project. I didn't create it, so I don't know why they didn't put it. But you know what HO, you stay the HO first, and then H1. Or depending on where the claim is, your claim is about the population mean. So just make a population. Boris, excuse me, Boris. Never had this name before. Okay. Now, so I go to my data set. And I say, okay, this is my mean. Sample mean. Okay.
Can you share your screen?
Not sharing it yet?
Yes, yeah.
Sample mean. Can you see it now?
Yes.
Sample mean is this.
Don't see that, Mommy.
Sample mean is equals average. You know what? Let me bring it down so I can have space there. Sample mean. I'll just type equals average. Okay. I go from here. Okay, close it. 20. Then population. Now, Mary, you there? Because you asked this question. Miss Mary, are you there?
Yes, Professor.
Now, see, they didn't give us the population mean. I can assume that the population mean is 22. Okay. Because they didn't give us. So make an assumption. This is a project. You know, when you are doing a research, you make your own assumption, as long as it is within the frame of what you are doing. If you look at what you have on the news about the coronavirus vaccine, the other company, huh?
Can I ask one question, please?
Yeah.
So can we just make up any assumption for the numbers? Because going back and forth on this and this, can we just make up any story or something just to get the numbers and all that? Because
that's what I'm doing here. I'm using my example. So I just showed you
okay
what you can do. Make an assumption maybe two points bigger than the population sample mean, or 3 points bigger than sample. So mine is only 2 points bigger than sample mean.
Okay.
Yeah. Then with that, you can now ready to do your test. So now, if you want to use the calculations that you want to do method we used last week, then you can just use this as a population mean. Already, you have your standard. You can get a standard deviation from this number here. Okay. How do you get that? I can show you standard deviation. Deviation. Now, remember we have a standard deviation. You can just let me make it bolder. So you have equals STDEV. Now you're looking for the standard deviation for the population. So STDEV.P. It's right here. Double click. That will give you then for the population. You can just highlight from here. That is if you're doing it manually. If you want to calculate manually, okay. Otherwise, you can just so you give us the standard deviation right here. Then sample size, how many numbers you have, and then from here I can put the samples of 1 all the way to the last number, to make it fast. I can just do it this way, and it will give me the it will number it all the way to the last one. See, sample size 22. So that n the sample size size n. So it's for here is 22 numbers. So Mary, I say, and the class and the rest of the class, I have answered that. So if you want to use the formula we used last week to test, you can be sure to type everything in. I want everything typed. Otherwise, you can just use Excel. Now, Excel does not have one sample test. Just like we have here when I was doing the histogram. I mean the frequency table.
Professor, I have a question.
Yes?
Yeah, this number that you just put, like 1 to 22, why did you do it?
Because I want to know the sample size. I mean, I want to know how many numbers I have here.
Oh, okay.
If you like, you can count it by yourself. 1, 2, 3. If that's what you want, yeah.
Oh, okay.
I just want to make it easy, Now, like when I was trying to do the history, the frequency table for you guys, Excel doesn't have that option. But when you want to create a histogram, it will give you the frequency table like this. So in the same way, when you want to do test of hypothesis for one sample, Excel doesn't for Z-test for one sample. Excel doesn't have it, but it has for 2 samples. So what we do is we trick Excel. We kind of give it some kind of a trick that that's it. We have 2 samples, and then we use that to do the hypothesis test. When we get the result, we now remove those, the one that we don't need. Let me show you how you can trick Excel. Let's say that this is the age and blood pressure, just the age, or maybe blood pressure. Or no. Let's say this is prices. I would say prices. I don't know what price, but now I will trick Excel by putting a dummy here. That dummy can be, let's say, 0, 0, just 0. So to make it think that we are doing a test for two samples, because it doesn't have for 1 sample. We have for 2. So with this dummy, Excel will be thinking that we are doing the difference between these two variables. So it will give us the result for 1. So now, hello? I can't hear you. Hello? Mr. Waters, can you mute yourself in the background? Hello? Mr. Waters, can you mute yourself? Mr. Waters too. Can you mute yourself and look, Mr. Wood? Okay.
Okay.
What did I do? Okay, I'm going to undo. Now, so we have tricked Excel by putting a dummy here. So it will thinking that then it can give us our result. So now we can now go and so okay, data analytics. So choose any of these. You say Z test two sample. Use the one for unequal variances. Okay, and then two sample as many equal variances. Yeah, as many equal variances will be better. Two sample means even Z test. This will give us variable 1. You can now use this one. Hold on, let me see if it has a label for us. Yep, you can use the variable 1 as your price. Okay. Then for the variable 2, because remember there's no variable 2, you're just trying to trick it so that it will give you the result you're looking for. Okay. This is unknown variances. If it doesn't give us, this should give us. So use dummy as variable 2. Okay. Now, but you know, we can't do. See, we can't do t-test for this one because remember, if you look at the project, it didn't mention anything about being normal. Am I right? Did it? It didn't say anything about normality. So use t-test. Use t-test. T-test will be better for us.
You want us to use t-test, Professor?
Because it doesn't. Project didn't say anything about normality. It didn't say. It didn't say that. Did he say that they are normal? It didn't. And remember, we also don't know this the population, the sample standard deviation, the population standard deviation. So we just estimated it here. Okay. So we just use t-test for this. So we have have this. So I'm gonna go back again. Data analysis. We have assume equal variances to this t-test. So that we have range, see the price, and then next it will be the variable 2. There is no variable 2. You have only one variable, but we are trying to trick Excel, make it think that we have variable 2 by using the dummy variable. You know, it is 0, 0. Okay. Then the difference, depending on the average. In this case, we are saying that if you look at let me move it down a little bit. Okay. I think I forgot the amount I got for population mean was 22, right? Yeah, I used 22 for population mean. I'm assuming that the price is equal population mean. Okay. So we don't use then we have that the price is less than no hypothesis that bigger price is equal to population 22. Then alternative might be that the price is less than that, $22. So I can choose the label. Then the critical value alpha is 0.05. It is given. Now the output range here, I can choose to put my output here. My results here. Okay. Then see my results here now. So now when it is in this form now, you can now pick what you remove those ones that I have to do with the difference. Now I have the mean. Okay, we have observation 22, observation price. Say dummy, you don't need dummy anymore, so you just remove the dummy. Okay,
Professor.
Huh?
We have this as part of one of our Excel.
I'm just saying if you want to use Excel to do this, to do the
okay.
to do that part.
I'm just saying that it's like I've seen this before, like we did it as part of a Zell assignment.
Now,
That's fine.
so the mean is this variance, then pool variance, you don't need pool variance, but if one, but hypothesized difference, mean difference, then T statistics, this you don't need anymore. So you remove. Then degree of freedom and every other thing, critical value. So you have all your results. You can just copy it from here. Okay. Copy. Oh, excuse me. Before you copy, type T test for the Z T test for the mean. So this will now be Z test. T test for the mean. Now, because we use a dummy variable, it will not. It will be fine. It will not be. The result is not a difference of mean. Okay. I just put here, and then copy this, and then go to your Word document. Okay, which is I think here, and then you can paste it here. Now, you can now remove all this because now you have pasted the results. Okay, you have a critical value. 1 tail, 2 tail, obviously 2 tails right here. If you're using if your test, your claim is a 2 tail test, you use this critical value. If it is 1 tail test, sorry, let me explain more. See, T statistic is right here. Your P value for 1 tail is here already, so you don't have to start calculating it manually like we did last week. Then, if your claim is, let's say that I say that the price is, there is no difference in price, then my alternative will be there's a difference. That means it's going to be 2 tail test. So if you're doing 2 tail tests, that means I'm going to use this. But if I say I think this price is less than 22, in that case, I'm going to use this one, P value for 1 tail and T for 1 tail. You see? So now with this, we can now decide whether to conclude. You know, remember the conclusion method that if I'm using the 1 tail, I see my calculated T statistics is negative then, but my critical value is 1.71, which is bigger than that. So I will say here, I'll type in here, I will reject a null hypothesis. Hypothesis is not rejected because the calculated here, calculated T, which is T of negative 0. Is right here, 171.96 is less than the critical value Okay. Now, if you're using one tail, your critical value is point. So look at T critical right here, 1.71, 1.71, 1.71, 3872, and the P value for the 1 tail is 0.43, 0.43. 248, which is greater than the alpha, 0.05. See? So that's your conclusion. Now, if you like, you can just remove this question here and just write your conclusion so that it will look, proportional. And then you can now then if your conclusion is that you do not reject, then you say if you're asked if you're asked what the conclusion means for this particular study, what you're gonna say? Okay, in my own case, I would say there is insufficient evidence. We did all this last week. Evidence to support the claim that the average price is less than or greater than, depending on your claim, $22. That's it. Project is finished. Miss Mary, you there? Miss Mary. She's gone. So I believe I have answered their questions elaborately about the project. So you can now go ahead and begin your project. Let us do what we have today, okay? Hello? You're all there.
Yeah, we are with you.
Yes, Professor, we're here.
Okay. Now, let us do what we have to. Today, we want to show you the last topic, and I think it's one of the homework. It's in one of the homework. We are finishing that handout. Like I said, I'm going to move the due date for all the assignment again to next Saturday so that you have time to finish it. And that day is also your final exam day. I posted a message on that. So you finish it. You can finish it before that, take your final exam, and the class is over. I'll put your final exam midnight, Friday night, midnight, even though I wrote from 1 to 3:30. I'm going to make it available in the midnight so that you have for the whole day to take it, to pick any time you want to take it. But once you start taking it, once you open it, you have to finish it. You cannot stop and go back to it again, okay? So when I put it there, if you want to take it in the morning, make sure you are ready for it. So prepare, then take it. If you want to take it in the evening that day, make sure you are ready. Anytime you want to take it that day, make sure that you are ready to finish it, because if once you leave it, you can't come back to it, okay?
I have a question about the final exam. Are you gonna have it like you had the midterm where we couldn't go back to the question before? Like, because I couldn't go over my work, make sure I did everything right.
Like that. Yeah, it's like just the same way you take your regular quiz, But the only difference is that when you start it, you have to finish it. You can't leave the exam and log out, then come back again. No, you can't do that. But you can choose to take it in the morning. I will make it available from midnight, like from 3 a.m. till 11 p.m. That's Saturday. Okay, so you can choose any time that is convenient for you to take it.
Okay. Oh, and I do have another question. On homework 17, it's a question that for the using the p-value method. And every time I do this question, no matter like using the same way you taught us how to do it last week, it's always wrong by 1 decimal. I can.
So the problem is that when you finish, then look at the how many decimal places they want you to put the answer in, because that could be the problem.
It's not. That's not the issue, because it says 4, and I put 4 decimals in there, but it's still wrong off by 1 decimal.
So the other numbers
are say like one of the numbers is wrong in it.
That is strange.
There is one that told me 3 decimal places, and I put it, and by the time it marks me wrong, when I check it, it used 2 decimal places. I'm like, did I know 3 decimal places again?
but the answers are the ones that are entered are good. It's just 1 decimal is off, right?
Yes.
So probably I you know, I don't know why. What is what homework is that?
That's 7.
17.
I mean 17.
You see, computers sometimes are strange. Homework 17. Hold on, let me get my write it down so that I can. How many questions? I'm going to look at your work there, see how many questions were affected. Then I can add extra the point that was taken off to you. Okay. So okay, this is Maths 107. 7. Homework. Say what homework? What again? Hello.
17.
Homework 17. Okay. You don't remember the question that did that?
It's the question I think is about like real estate or something, but I do know that the mean is always 117.91 on that question, no matter how many times it give me a new question.
So that the question was I want you to find the p-value, and for that particular question, you find the p-value and it says wrong.
It tell you to find the p-value, and it just every time I find it, the same way you taught us, no matter if I use Desmo calculator on my computer, calculator on my phone, it's always the right answer, like with all of those calculators. But when I put it in the computer to check the answer, it says it's wrong by one of those decimals.
Yeah, that's what I want to know. Yeah, the question that does that, I'm going to look at those ones that ask to find p-value and put back the point in Canvas. That's why I want to know what question is that. You don't remember?
It's like between 1 and 4, but like question 1, 2, 3, or 4.
Like
I
3
can't
of them,
remember
right?
which one though.
Like 3 questions, right?
Well, it's only one. I've been stuck on the same question, so I don't know how many questions is like that. I've been just trying to get this one.
So anyway, do the rest of the work on that homework 17. Okay. So I'll go and check how many points that p-value is, and then I'm going to add it to you when you finish in Canvas. So it will not be the, let's say you have a score of 70 or 90, whatever. I'll put the point for the p-value so that it will boost it back. So you don't lose the p-value point. Okay.
Okay, thank you.
Okay. Now let us do this. I'm gonna close some of these things so I can have room. Close this one. Okay. Now I will go to what we have today. So I'm gonna close this one too. Correlation and regression. Okay. Now, correlation and regression, we use them when we want to check relationship between 2 variables, or even more than two variables. Now, we use them to answer some question like this here. Is the volume of sales in a given month related to advertisement? Now, that means, let's say that sales is the Y variable and advertisement is the X. If we advertise more, do we sell more? See, is advertisement related to sales? See, 2 variables. So we want to check the relationship between these 2 variables. We use either correlation and regression. We can answer, some educators may be asking, number of hours a student studies, is it related to score they will have in the exam? Or something like, many questions we answer with them with correlation and regression. Is caffeine related to heart damage, for example? Is there a relationship between a person's age and his or her blood pressure? You know, so these kind of questions, we answer them using correlation and regression. So correlation simply means a statistical measure of that indicates the extent in which two variables move together or fluctuate together. For the regression, it means we use it to determine the strength of the relationship between the two variables, So now there are some terms we use when we do correlation and regression. First one is the dependent variable. The dependent variable are the variables that we can not control. For example, your grades. You may study hard, and of course, when you study hard, you will have a good grade. But you cannot control whether the grade will be 90, be an A or B or C. But you can influence it, But you cannot say I'm exactly going to have A. Of course, you can have A, but sometimes even when you study hard, they might ask one question that have so many points, or maybe one assignment has so much point, and you didn't do well in that one. It might push you back to B. That's something that we can't control. I will give you another example. That they say that if you drive slowly, according to the speed limit, you won't have accident, right? Yeah, but it's true. But sometimes you might be driving, but doing the right thing. Somebody else might come and hit you. So there are so many other variables that we can't control, even though we follow the rules. Another example: exercise and good health. Exercise gives good health, but even though you exercise, you cannot say, I'm not going to have coronavirus, or I'm not going to have cancer. Of course, exercise decreases your chance of having those things, but you cannot determine how good your health will be. All you can do is I can improve my health by doing exercise. But exercise you can control. You can say, I'm going to do only 5 hours today in the gym, or 2 hours or 30 minutes. You can control that. In the same way, you can control your speed limit. I can drive only 30 miles an hour. But the effect, you have no control. So those variables we can control, we call them the Y variable or the dependent variable. The one that we can control. The one we can control, we call the independent variable or the X variable. And we check in correlation and regression, we figure out the relationship between these two variables using correlation or regression. So there's one variable we calculate, one statistic we calculate to figure out the relationship between these variables. We call it the correlation coefficient rho. The one we'll be doing for this class is called the Pearson correlation coefficient. Then we also figure out the determination of these two variables, coefficient of determination that will tell us the extent to which X causes Y. Then another thing we need to get is the regression equation. Y equals B0 plus B1X. Y is of course, the dependent variable. B0 is the intercept, and B1 is the slope. I will show you how we can use all these things, okay? Now, so if you want to do this using formula, it can take you the whole day. These are the formulas you need to calculate. Calculate all this. Then at the end, you can now figure out your R. It will be a long calculation. You have to make a long table of values. But with Excel, you can do it in a few minutes. So I'm going to show you very soon, okay? Hello, you guys are there? Hello?
Yes.
So now, like I said, we're not gonna be using the this method. I use Excel for you, and I recommend you use it to do correlation and regression. Because if you use this method, it's gonna take you along, and the chance of you making a mistake will be high. So how do we do that? Now let's look at the first example. It says progress exercise. It says let's do maybe 2 of them, or even 1. Yeah, there's no, it doesn't. I don't want to keep you here more than I should, so that I'll be able to, you can have time to finish the remaining homework, and then and also answer some questions. And so let's do this. This one doesn't have all the questions we need. So let's do the one that has all the questions. Like this one here. It says the table below shows the mileage and prices for 8 cars. Mileage, price. Then it says construct a scatter plot. A scatter diagram is a diagram that will show you how related they are. You just like a drawing the regular graph. then calculate the correlation coefficient R, compute the R square, which is the coefficient of determination, then find the regression equation. Then what is the predicted price for a car with 45,000 miles? Then is there a relationship between the two? So we're going to answer all these questions using Excel. It make it faster for us. You are ready?
Yes.
Yes.
So let's do it then. So now you copy this from here because you want to draw a scatter diagram. Let's answer the first question. The scatter diagram. Solution. Okay. Now you copy from here, mileage and price. Remember, all these are in thousands, see? In thousands. Which means that this one means 21.8 means 21,800. 34 means 34,000. In a similar way, the price, you have 34,000 miles. This one is mileage. Excuse me. 41.7 means 41,700 miles. For price, 16 means $16,000. 11.5 means $11,500. So I remove the zeros to make it simple, you know. Now, so you copy all this. Okay. Instead of typing it, just copy it and paste it in your Excel file. Okay. Okay. Paste the idea now. See, they're all there. Now, this is the mileage. Mileage. This is the price. So let me move this on the other side so you can always see me. Now, so we are ready to do your regression and correlation at the same time. So we got data analysis. Now, we are looking for the scatter plot, but one example we do, one calculation we do will give us everything, both the scatter plot and all the values we need. We look for regression, which is right here. Okay. Now for the Y variable is the price, because mileage, we cannot control the price. There's a car of, and we know that, of course, common sense tells us that the higher the mileage, the lower the price. But we cannot, I can't say that, I cannot see a car. I say, okay, this car is 100,000 miles. Therefore, the price will be this. No, I can't. The price will be lower, yes, but I cannot decide this by myself. I can't control it. It's only the market will decide that. But I can say, I want to drive only 30, I'm going to buy only a car that is less than 100,000 miles. I can decide that. I can control that one, you know. So in this case, the price is our dependent variable, which is Y. Okay. And the mileage is our X variable, which is the range, S range. Now, notice that we are including the names. Notice that we're including the names here. So we're going to check the label. So check labels here. If we need confidence interval, we can check this, but we're not doing confidence. Okay, so we don't worry about that. And output range. I want the output to be below it. Okay. Then I need the scatter plots too. So I'm gonna check this. Okay, then I click OK. See, you give us everything. See, you give us the R right here. Plot, it has a scatter plot somewhere. Let me see where it has a scatter plot. Yep, you can see the scatter plot right here. Mileage and price. See? Mileage and price. Now, I want you to give us everything in here because if you look at our question here, the question also wants us to get the regression equation. So I can get it straight from the graph, or I can get it from the chart, from the So now let's see. Now we have our scatter plots. All we have to do now is to copy the scatter plots here and then paste it after adjusting it. This is mileage and price. Okay. Yeah. What did I do? Okay, let me see. I think something happened to our graph. Didn't see our graph anymore. What happened to our graph? Okay, I can put the graph again. You guys are there?
Yes.
Yes.
Back. So I'm gonna do undo again. So I can bring it here. Yep, mileage and price. Okay. And price. So I can format it, make it size, let's say 10.11 should be good enough. And I can now remove this price. I can just copy it from here. Then go to your work, our book, and then paste it there. That means I didn't copy it right. So maybe go and copy it again. I didn't copy it right. I click on here, then Control copy, copy. Then go to our workbook. Then Control V. It's there. So if you like, you can make it bigger. If you like, adjust it. Now we answered part A. Any question on this? Any question? No question. Very good. Now, as B says,
Professor, I have a question. What about if we have this type of problem in an homework like the assignment? Are we going to be able to copy and paste the graph?
No, in the homework, it won't give you you won't be able to do the graph because it will tell you, it will give you numbers and you use your mouse to click. It will give you the graph already. So what you're gonna do is you can do this in Excel. Then you look at the option, the graph option he gave you. Choose the one that looks like this one as the answer. You click it. Are you getting me? Hello?
Miss, yes, I got it.
Yeah, it will give you like it will draw 5 different graphs. So you can now go to Excel, use the data he gave you in the homework and draw the graph, get the scatter plot. Then they can now compare it with the graph shown in the options, then choose the correct option. See what I mean? So you can see the scatter plot may show that it's trending down. This shows whenever it's going down this way, we say that it is negative correlation. So when it trend down, but if it's trending up, it's positive. What do I mean by that? Sometimes you might have a graph like this. Let's say that this is a graph. You have the X and the Y axis. Okay. And this is your Y axis. And then the X axis is like this. And it's going this way. It's your X axis. Okay. Now, if you have it in this form, okay. Oh, excuse me, let me if you have it in this form, X. Then, we are plotting the point X, just using a small example. Something like this. See that unlike this one that is trending down, this one is trending up. We say that it is positive correlation. But this one is trending down, it's negative. Now, sometimes you might have one that is scattered. It means that there's no relationship at all. Yeah. So now, that's why I say find the R, the correlation coefficient R. In that case, Excel he gives us to us already. It is here. So we have an R right here. Say multiple correlation, multiple R, 0.757. I mean, if you write to 3 decimal places, 0.758. Okay, for R 0.758. Just write it down. Okay, R equals 0.758. So now, because this thing, our scatter plot is showing us negative, so it's gonna be a negative answer. Negative 758. So R. So what does this mean? It means that when S goes up, Y goes down, and when Y goes up, S is the opposite. So that means when the mileage is high, price goes down, and when mileage is low, price goes up. So let's explain interpretation. So the correlation coefficient of R equals negative 0.578758 means that there is a negative, well, it is 0.75, which is very close to 1. It's close to 100. 1, it means 100. So it's going to be a strong negative linear relationship between X, between the X, which is the price, which is your Y variable, and mileage, which is your X variable. Now, which means that when mileage increases, that is when mileage increases, the price also increases. The price decreases, and vice versa. Okay. Any questions to this?
Professor.
Yeah.
The R, are we just gonna get it from the Excel table that we did?
What was that?
The R.
Yeah, we did it from. If you see, once we did the calculation, Excel give us everything. It's right here. Like I said, that if you are solving this kind of question in a homework, once you get it, just come here and pick your R. If you say 3 decimal places, stop at 3 decimal places. If you say 1, Excel gives just right away. He gave us everything at once. He gave us the scatter plot. He gave us the R. He also give us the Y, the regression equation as well. Okay. So all this number, he gave us even more than that. A lot of things. He gave us the p-value, everything. That's the good thing about using Excel. Okay.
Okay.
So next one, it says compute the R square. Say R square. R square is the coefficient of determination. Solution And R square is just what it means. R square means you square this one. But the good thing is Excel give us the answer already. You can see it right here. It has the R square. See? Idea. So it's a 0.57423. Okay. So that means this means 0.5. Let me write it down. 0.57423. So we have it as R squared. So R squared is 0.574. I usually stop at 3 decimal places, or you can call it 57.4%. Now, before I explain what it means, I want to take you back to our regression equation. I mean, the last example we did, which is a correlation coefficient of this. Now, how do I know that it is strong? Because it ranges from -1 to 0 to +1. See, that is R, ranging from that. If you look at this, it goes from here. Okay. This one indicates a strong negative linear relationship. Okay. Relationship. Now, at the middle, where we have the 0, excuse me. At the middle, where we have the 0, means no linear relationship, no linear, okay, relationship.
No.
And here we are almost finishing, so just be patient, okay? Have strong positive, okay, linear relationship. Now, answer was 0.758, which should be around here. You know, negative 0.758, which should be actually around. So even though it's negative, but it's strong, it's getting close to 1, to -1. When it's -1, you know that the price is this. I mean, the mileage is this. The price will be exactly that, but it's not always the case. If it's on the right side, positive, it will be, that means when price increases, when mileage increases, price increases. But here it's on the left side, which is negative. In that case, when the mileage increases, price decreases. Okay, that's why I say that it is a strong negative relationship between these two variables, and that means that mileage increases, price decreases. Now, for R squared, we find the value. Instead, give us the value as 0.574, which means 57.4%. See, what does this mean? The R square of 57.4% of, sorry, my mistake, of, let me correct this, okay, of 0.574 means that mileage causes or explains 57.4% of the decrease in the price of the car. It explains only 57. That means the other variables. Because I have seen a car that is have a high mileage, but the price was still high. Maybe because of the quality of the car, you know, stuff like that. We even have what the car they call antique cars that even cost more than the current car in new cars, you know. So mileage explains only 57.4% according to this our data. Any questions? Questions? Hello, class.
No question.
Yeah. And the regression equation solution. There are two ways you can get the regression equation. You can just get it by looking at your data. Remember the general format is y equals beta 0, which is the slope intercept, plus beta 1 x. Okay. So where beta 1 is the b1 is the slope. Okay. And then b0 is the intercept. Now, excuse me, a mistake. Okay. Now, this is the general form of this equation. Now, we're looking for we need the b0 and b1 to complete the equation. Okay. Now, we can get it from two ways. We go to our Excel, and you can see that they have it here. We have see where we have the coefficients. This is your beta 0 right here. This is our beta 1. So let me write them down. Our beta 0 is the intercept is 17 point b0 is 17 point. I will stop at the third decimal place. 100, and b1 is negative 0 point. You can see b1 right here. This is the mileage. See mileage, negative 0.090. So, or you can make Excel to put it in the chart. So let me take it back here. So I have our B0 from the Excel. We have our B0. Our B0 equals 17.100 and, well, actually it's B0, but this is changing it to big B0. And the B1 equals negative 0.090. Okay, so our equation now becomes y equals 17.100 plus negative 0.090 x, which give us, if we simplify this, as y equals 17.100 minus, because positive times negative is negative. Now 0.090 x. See, we have it right there. Now, and what does this mean? It means that, see, it is negative. Our slope is negative. Remember, all these are in thousands. So if you multiply it by 1,000, that means like, let's see, 0.090 times 1,000. I hope you have 0.090 times 1,000. Where's my decimals? So I have 0.090 times 1,000, $90. So so take you back here. So because it's negative, this means that the slope of negative 0.090 means that the price of the car decreases at the rate of why decrease? Decrease means that because it's negative. If it's positive, it means increase. Rate of $90 for each 1,000 increase in mileage. See, that's what it means. It's look. Questions? Any questions?
I have a question. Where did you get those numbers 1700 and those B0 and B1, the numbers?
Excel. Let me show you. An Excel right here. You look at it. You know, Excel gives us a lot of things. So for this one, if you go on this table, you can see where I have the coefficient.
Okay.
The first coefficient is the intercept, which is 17.0. That's how I get them. The second one is the mileage, which is negative 0.090. You see that?
Yes.
Any other question? Okay, no other question. Good, very good. Now, next one was, what is the price? What will be the price? Let me move it down a little bit. The price, the predicted price of a car that is 45,000 miles. Okay. Again, Excel have given us the result. Now we have our equation right here. Let me copy it from here and paste it here. That will help us to answer the question. In this solution, in this case, X is 45,000 miles. That means X is 45. See? Remember, I told you at the beginning that all these things are in thousands. So I remove the 3 zeros. So I'm going to do the same here. When S is 45,000 miles, that means S is 45. So I'm going to plug it into the equation that we have, what we just did right here. So that means Y becomes 17.100 minus 0.090 times, I plug in 1445 for X. That will give us the price of this car. Let me take you to this most. Right, put this in down. Let me write it down first. Y equals 17.1 minus 0.09045. Let's go to decimal, see what it will give us. We'll have it here. $17.1 minus parenthesis 0.090 times 45, 13.05, 13.05, which means 13,050, because if you multiply by 1,000. Okay, so take it back to the work. Call it 13.05, which is, or you can call it 13,050. So that means a car that has a mileage of 45,000 miles costs 13,050. Any question on that? Questions? The last example before we leave. It says,
I'm sorry.
Go ahead, ask. Ask your question.
Oh, well, I was supposed to talk to you after class.
Okay.
I thought you were saying that class was over.
Okay, yes, sure. This is Megan, right?
Yeah.
Okay, yeah, sure. Now, To answer this question, you say, is there a relationship between mileage and car price? Let's say a HO, we still our hypothesis, HO, mileage and car are not linearly related. X and Y, mileage, which is an X. Actually, we start with this. Beta 1, B1 is equal to B2, equal to 0. Okay, that means that it means that mileage and car, that is mileage X and price and price are not linearly related. Okay, and H1, beta 1 is not equal to 0. That is okay. That mileage and car, mileage and price are linearly related. Okay, are linearly related. Mileage and price are linearly related. So now again, Excel will give us the results. Let's look at the p-value we have. The p-value Excel gave us the p-value. If it was our alpha is I think it's 0.05 they gave us, I think. Let's look at the question. I think it's 0.05. I'm gonna, this thing always changes. I don't know why. Probably because alpha in Greek means a, who knows? So let me take you back. It says to use, I think the question says use alpha, right? Yes, it says use alpha 0.05. If the p-value is less than alpha, we reject null hypothesis. So let's look at our alpha. I mean p-value from the Excel. He gave us the p-value as, what is it again? Okay, I'm gonna move it all the way back. See the p-value right here. See, for the slope, that's for the see, it's 0.0294. Because 0.0294. Actually, it goes 938, all the way to 1. But I saw as a 4 decimal place. So you're gonna be 0.0294. So because the p-value is less than the alpha 0.05, we reject HO. I reject the null hypothesis. Okay, because the p-value is less than okay, because the p-value of 0.0294 is less than the given alpha. So it's less than 0.05 to the alpha. So you reject the null hypothesis. Okay. So that means you are rejecting this. That means you are accepting the alternative. That is that their mileage are related. Conclusion: mileage and price are linearly related. Any question? Any question? Okay, let me take your name before we leave. I have Mary, I have Carrington, I have Owotutu, and I also have carelessly. So Shadona Wrigley. Okay, Shadona is here. Okay, 5 people now. Who else is here? Elizabeth. Elizabeth, you still there?
Yes.
So we can leave, right?
Well, if you want to keep us company, you can keep us company. But otherwise, they're free to go. It's a free contract. It's a free contract after all. Yes. Is Janelle here? See here?
You're gonna send us this, right?
Yes.
Okay, because this is like the homework aid. I opened it when I saw the equation. I just closed it.
Okay.
I saw the way they multiply x and then y. I said, "Woo, I'm not gonna do this."
Yeah, no problem. I will send it to you. Sure. Who else is here? Who else? I want to see everybody.
Megan Davis.
Davis is here. Okay. And I have, okay, I think I have everybody that is here. All right. I see you next. I see. Well, again, this is it because next week you won't see me anymore, but you will see my exam. So I enjoy your holiday. Okay.
Professor.
Yes, ma'am.
This is Megan Davis.
Megan, yeah, you say you couldn't open the attachment.
Yeah, I can't open it. I'm like, I don't even see an attachment on it.
Attachment?
No, I sent you a screenshot of the exact message that I got.
So let me show. Let me see if I can. Let me open that. Let me open that. The email I sent you. Okay. Let's see. Okay, I have well, I have a lot of emails, so I have to send. I think I sent it twice,
it's
right?
fine.
I think I sent it twice, right?
No, I don't think you sent it twice. I think when I asked you the second time, you said that it was in the first one. It was in the first email, and you told me that I could how to go in, and you sent me an attachment about how to get rid of cookies. Because you said something about cookies could have been up, or I didn't open the cookies or something. Huh?
An email right here sent to you. Can you see it now? I see the attachment right here.
Yes, I see it. I see it on there. I see it at the top.
When you send it, when you open your own, can you see? Did you see it?
Let me go and try to open it.
The email went on the 17th. Check the email I sent on Tuesday on 17th.
On Tuesday.
Of 17th of this November. That's when I sent it to you. And it will take care of homework 7, 8, and 9. That's what I said.
Okay. Yeah, I opened it. Like it's no attachment on there.
You don't see you don't see it at all.
No.
Let us try this.
Is it possible you could send it to my personal email?
No. What's your personal email?
Megan DVS.
Hold on, Megan. You can see the screen, right? You can see my screen,
yes.
right?
Yes, I can see your screen.
Let me forward it to you now. So your email again is hold I'm going to forward it to you. So now, excuse me. Let me close this. Okay. So you, I don't know why it's messing up like this. I can. Megan, so is it Meg? Hello, Megan, you there? Megan? Hello? Megan? How's yourself? Megan, you there? Okay, look at what I'm going to do. I have no system here. Not clear out. I'm sending there to PDF. Okay, let me send it to this thing. We save it. Megan. Save anyone. Megan. It's in there to her mind account.
Professor.
Yes.
Oh, I wanted to talk to you because I sent you a text on, not a text, but like a message on Canvas or something
You're speaking now.
about the Excel.
You're speaking now.
Huh?
You're speaking.
I'm sorry, I can't hear you.
Am I speaking to?
Oh, Elizabeth.
Elizabeth, okay, yeah, okay.
So, I missed some of the Excel assignments because my first laptop had broken around the time. I can't remember the exact time, but some homework were due, but I couldn't do only had the Excel assignments left. So I couldn't do those and was past due because my laptop was broken. So I had to wait to get a new one the following week. And when I tried doing the Excel assignment, one is a little confusing, and second, some of the I tried following the instructions, but the Excel I have on my Chromebook, the new laptop I just got, like some functions are not in there. So I'm not really familiar with Excel.
What is your question then? You what is the question then? I want to know because the Excel assignment have to be done using Excel. You know what I mean? So
yeah. Is there a video of like maybe, but like when we're using, you were talking about how to do the Excel assignment? Maybe there's
there are plenty of videos, you know, that you can use. it depends on what you want to do. If you want to find the mean, there's a video for find. You just go to. Let me see if I can. You can see my screen, right?
Yes.
Good. Now, suppose you want to find those that are given there. You want to find the mean. You just go to YouTube. Okay. I even have some. I made some videos myself too in YouTube. And yeah.
Okay. Can you tell me the name of the YouTube channel? Maybe I can just use that.
Depends on the what you want to do. So let me see. My own. Just type my name. You go to you see. Can you see this place?
Yes.
Yes. Just type my name. I don't name of my channel. I don't remember the name of my channel, but you can just type my name. It will bring all the videos I make. See, all these are all my videos.
Oh, okay.
So you can choose the one you like for. Most of them are using formulas, but what you're looking for is how to do it in Excel, right?
Yes, that's it.
I haven't gotten to that point yet. So in that case, what you need is just type it here. For example, finding the mean using Excel. Just type finding mean in Excel. Once you put it, it will give you all these options. You see this one? Calculating mean, median, mode, and in Excel. You can see right here. You click on this, it will guide. You see?
Oh, okay. I'll do that.
There are many of them. So if you watch this one, if you don't understand this person's method, you can go back and choose another one.
All right.
Yeah, that will guide you in all those. When you start doing it, you see that it is actually easy.
Oh, thank you.
You're welcome. All right, have a good weekend there.
You too.
Bye-bye. So let me save. Let me close this part. Huh? I know. Okay. Can advertise it. Yeah, baby. Record this.